This test assesses whether the variances of the two groups are equal. This assumption is important for interpreting the results of the t-test. F, for this case right here, this test statistic for Levine's test, which compares the ratios of variance of the two groups. And sig, the p-value associated with the F statistic, in this case, the p-value is 0.187, which is greater than 0.05. Therefore, we do not have to reject the null hypothesis of equal variances. This means that we assume equal variances for the subsequent t-test. And so then our t-test for equality of means. This section provides the results of independent samples t-test itself, which compares the means of the two groups. The test statistic, which measures the size of the difference relative to the variability in the data. In this case, the t-value is negative 0.272. And then the next thing we got is our TF, which we already know. The degrees of freedom for the t-test for equivalent variances is assumed, DF is 8. For equal variances, not assumed. DF is approximately 6.6110. Or 610. And the significance for the one-sided p, the p-value for a one-tailed test of the hypotheses that group 1 has a lower mean than group 2. For the two-sided p, the p-value for the two-tailed test, which is more commonly used, both one-sided and two-sided p-values are provided for both assumptions of equal and unequal variances. Mean difference. So our mean difference represents the difference between the means of group 1 and group 2. In this case, the mean difference is negative 1.00000. And our standard error difference, the standard error associated with the difference between the means, which is 3.67696. And then finally we got to our 95 confidence interval of the difference, and indicates the range within which we can be 95% confident that the true mean difference lies. For equal variances assumed, it ranges from negative 9.47907 to 7.47907. For equal variances not assumed, it ranges from negative 9.79971 to 7.79971. Now let's move on to the independent samples effect sizes. This section provides various effect size measures to quantify the magnitude of the differences between the two groups. Cohen-D's standard measure of effect size, calculated area, we've already gone over that, but which is calculated as the mean difference divided by the pooled standard deviation. In this case, Cohen-D's is negative 0.172, indicating a small effect size. Hedges correlation, on the other hand, over here, or correction, is similar to Cohen-D's but adjusted for small sample sizes. Hedges correction is negative 0.155. And for glass delta, another measurement of effect size using the standard deviation of control of the control group. The glass delta is negative 0.234. Now to summarize the interpretation of all these separate groups, so the group statistics, both groups have similar means, 83.6 for group 1 and 84.6 for group 2, and relatively small standard deviations. So that's what we concluded from group statistics. From Levine's test, it indicated that the assumption of equal variances between the groups is reasonable, since the p is equal to 0.187. For the t-test results, the t-test showed no statistically significant differences between the means of the two groups, as indicated by the p-values. And the mean difference and confidence interval, the mean difference is small, and the confidence interval includes 0, suggesting no significant difference between the groups. And for our effect sizes, all measures of effect sizes, Cohen-D's, Hedges correction, and Glass's delta, indicate small effects, reinforcing the finding that definitions between the groups is minimal. Yeah. Based on these results, there's no statistically significant difference between the means of group 1 and group 2. The effect sizes also indicates that any observed differences are small and not practically significant. This, through analysis, helps researchers interpret the significance and magnitude of differences between independent groups in their studies. Yeah. Now, for my conclusion. In conclusion, we have learned what a t-test is, when to use it, how to perform it in SPSS, and how to interpret the results. The t-test is a powerful tool for comparing means between two groups. I encourage you to practice performing t-tests with different data sets to become more comfortable with SPSS and the statistical analysis, and statistical analysis in general. Thank you for your attention and your participation.